So this is going to get broken up into two sections. The first section we're going to do is the area with respect to x. So if I have two curves, so what I want you guys to do is, if you guys have different colored pencils, this would be good, or pens. What I want you guys to do is just draw with one color. I want you guys just to draw just like a random function, something like this. And I'm going to call this f of x. So let's say, guys, I want to find the area under the curve from -1 to 4. So do you guys agree that if I want to find the area under the curve, I'd be finding this light blue area? Something that looks like all of this, right? And if I knew what the equation was, couldn't I just take the integral of that and figure it out? You guys follow me? Okay. What we're going to do now is, what if we have a second function that is on the graph? So something maybe that looks like this. Actually, that's bad. I don't want to do that. Maybe something like that. So I'm going to call this g of x. If I want to find the area under the curve of g of x from -1 to 4, I guess. Do you guys agree that'd be something like this area? So what we're trying to find is the area between them. So do you guys agree the area between them is this part? Okay. So what would be nice to know is the bounds. So do you guys see how the two graphs intersect right there? And they also intersect right there. So this point right here, I'm going to call A. And then this second point right here, I'm going to call B. And this is actually a good kind of example to show you guys, is because are these nice numbers? No. Our calculator though, and I'm going to review with you guys how to do this, our calculator can find where two graphs intersect, but we also can find out algebraically by hand if they're nice functions. Okay? How could I figure out the area under the curve, between the curves? So do you guys agree which function is f of x, the blue or the red? The blue. So do you guys agree the area under the curve of f of x is all the blue? The area under the curve of the g of x is just the red, right? So do you guys agree where both under the curve would be blue and red? I don't want that. I just want this part. So what would be a way mathematically to do that? No, I'm good. Okay, thank you. Subtract. What is the function that I would subtract first? What would go first? Which is the higher function? Okay. What? F of x. So the rule that we're going to follow is whatever is a top function, you're going to take that area and subtract the bottom function. Because if I subtract the blue area minus the red area, I'm going to get just the area I want. Okay? So the area under the curve is going to be from a to b, the integral from a to b of f of x minus g of x dx, where excuse me, f of x is greater than or equal to g of x for all x in a to b. What this means is like all the y values are higher than all the y values for g between our 2 points where they cross. Okay? So not only do we have to integrate now, we have to find where they cross and then do some simplification. Okay, so these problems take a little bit more work. Okay, so we're going to start with something easy. So let's look at problem number 1. So this, no pressure. This is going to require us to remember what some functions look like. So it says find the area bounded by the curves of y is equal to x squared plus 2, y is equal to negative x is equal to 0, and x is equal to 1. So this problem's nice because they gave us the graph already. But do you guys think, just from the level of this class, that you guys will always have the graph? And the answer is no. So you're going to have to remember what some graphs look like sometimes. Okay, so x squared plus 2. What type of function is this? Parabola, right? Y is equal to negative x. It's linear, right? With a negative slope, right? So do you guys see that? We have a line that's decreasing, and we have a parabola that is translated 2 units up. So this is my x squared plus 2. This is my y equals negative x, okay? And then we're bounded by the lines x equals 0 and x equals 1. So do you guys agree x equals 0 is there? And x equals 1 would be this line. So basically, I want to find the area between this parabola and this line. This section is with respect to x. So with respect to x, so between these 2 points. So do you guys agree that that area then is this shape? Right here. Okay, so unfortunately, this is not like a perfect geometric shape, so I'm going to have to do an integral. So this is where our function knowledge is going to come into play later, but since we have a picture, this is pretty easy. The formula is the integral from a to b. So area is equal to the integral from a to b. What is our a? On the x-axis, where on the x-axis does this green region start? 0. And it ends at 1. Okay? Our formula says f of x minus g of x. So which function is higher? The parabola. So the parabola, so this is going to be our f of x. And this is going to be our g of x. You guys follow me? So it's going to be x squared plus 2 minus g of x, which is negative x, with respect to x, dx. Okay. Cool. I can simplify before I integrate. So the double negative becomes a positive. So this is going to be the integral from 0 to 1 of x squared plus x plus 2 dx. And then I can just do my antiderivatives. What's the antiderivative of x squared? Good. So x cubed over 3 plus x squared over 2 plus 2x from 0 to 1. Now notice that all these have an x, right? So when I do my bounds, when I plug in a 0, what are all these going to become? 0. So do we really care about the 0? So we really just have to plug in 1, plug in 1, plug in 1. So this is going to be, if I plug in 1, what's 1 cubed? 1. So 1 cubed is 1, so 1/3. Plus, if I plug in 1, 1 squared is 1 over 2, so plus 1/2. Plus, if I plug in 1, this becomes 2. You guys are calculus students, so I'm assuming you guys know how to add fractions. But if you add all these together, you get 17/6. Okay. So what's today? Thursday. Today's Thursday. Yes, today's the 27th. These problems can be kind of long, so I'm giving you guys till Sunday on purpose to do your assignment. I would like you guys to start it today, if you guys can. I know some of you guys have championship games today, so I understand. Remember, guys, extra credit if you guys go tonight. Huh? You just come find me. I'll be there. I'm going to be handing out pom-poms. All right. Here's a good example of something you guys will see on an AP exam. Find the area bounded by y is equal to 2 minus x squared and y is equal to x. Okay? That's all they give us. Okay? So, couple things. What does the graph look like? So, assuming you don't have a calculator right now, okay? What would the graph look like? And then we need an A and a B, right? So we need to know, where do they cross? So because I have my iPad, I have the luxury of like writing and then shrinking my writing if I run out of space. Because you guys don't have that luxury, some of you guys, please write small right here. So that way you guys, everything fits. Okay, so quadratics. Do you guys remember that those are U-shaped? If it's negative, do you guys agree it just means it's upside down, right? What does the plus 2 do to the graph? 2 units up. Okay, so that's why we like drilled that to you guys in Math 3 and in pre-cal, because we need you guys to be comfortable with that. So does my graph have to be perfect? No. So I'm just going to draw something that looks like this. And then y is equal to x. That's a line where the slope is 1. Is there a b? No, so what is it? 0. So it's a line that crosses the x-axis at 0 that has a slope of 1, up 1, over 1. So it's going to look something like that. So again, like our graph's not going to be perfect, right? And that's okay. But visually, can we see now the area between the two curves is going to be something that looks like this blue area? Does that make sense? Yeah? Okay. So this is how you find where they cross. Where the graphs cross is where the two functions are equal to each other. So because one's quadratic and because one is linear, we can find where they cross algebraically pretty easy. So to find the intersection points, we're going to say that 2 minus x squared is equal to x and solve for x. Did I lose anybody? Does this make sense? So because it's quadratic, do you guys agree I want everything on the side that has the x squared? So I'm going to subtract x from both sides and then rewrite it. So I have negative x squared minus x plus 2 is equal to 0. Because maybe this factors, it does. In case it factors, I would really like this to be a positive. So what I could do is just multiply everything by -1. So I'm going to get x squared plus x minus 2 is equal to 0. Factor. So we get x plus 2, x minus 1 is equal to 0. What are my solutions? X equals -2 or x is equal to 1. Okay? Now just think logically, right? A to B, so we're going left to right. Which one is A? -2, so this is our A. This is our B. Okay, now I'm recording this in case you guys want to come back and look at this when you guys are doing your homework. From the graph, which is our f of x? Which is our top function? The parabola or the line? The parabola, which means this is our g of x because it's below. Let's say, for example, you solved and got the bounds, but you don't know for sure what the graph looks like. What's the higher function? What I would do, and this is being recorded, is pick a number that is between these two numbers. So what would be the smartest number to pick? 0. Plug in 0 into this guy, plug in 0 into this guy, and see which one is bigger. If I plug in 0 into here, what's y? 2. If I plug in 0 into here, what's y? Which one is bigger? The 2. So this would be your f of x then, because that's the larger. Does that make sense? Okay, so graphically, we're good there. But in case you guys couldn't graph it, that means that this is your f of x. And this is your g of x. Okay? All right, so that means our area is going to be the integral from -2 to 1 of f of x minus g of x dx. Okay? So if I do the antiderivative, this is going to equal 2x minus x cubed over 3 minus x squared over 2 from -2 to 1. So unfortunately, I don't have any zeros here. So I have to do the math. So if I plug in 1, I'm going to get 2 minus 1/3 minus 1/2 minus. If I plug in -2, what am I going to get, guys? -4. What's -2 cubed? Positive or negative? -8. So -8 becomes +8. If I plug in -2, -2 squared is 4. So minus 4/2 is just -2. Okay? To make my life easier, what I could do is, notice I have denominators of 3 and denominators of 2. What's the common denominator? 6. So I'm going to turn everything into 6 is. So this is 12/6 minus, 12s. I'm going to turn everything into 12s, my bad. No, 6. Multiply this by 2. 2/6 minus 3/6 minus, what would -4 become? -24/6 plus 16/6, right? Minus 12/6. Is everybody cool with how I did that? Yeah? I mean, I know you guys aren't cool with fractions, but hopefully the steps make sense. Okay, so what's 12 minus 2? 10 minus 3? So this would be 7/6 minus -24 plus 16 is -8 minus 12 is -20. So minus -20 becomes plus 20 over 6. So this becomes 27/6. Does that reduce? It does. What goes into 6 also goes into 27? What? 3. So this becomes 9 over 2. On an AP exam, if this was an FRQ, okay, so in my class, if you guys get here, you guys would get most of the points. Like if it's out of 5 points, I would give you 4 points if you guys get to here. But to get the full point, I would, in class, just to practice, I would want you to get to here. Okay, but just understand on an FRQ, if you guys got to here and stopped, you would get full credit. Because you're showing you know the calculus to get from the integral, the graph, all the way to here. Does that make sense? Okay, so, but I do want you guys to practice this because you guys could have multiple choice questions. Is this going to be one of your multiple choice answers, you guys think? No, this is going to be the multiple choice answer, okay? All right, questions on number 2. 3. Set up the integral that allows you to find the area in the first quadrant that is bounded above by y is equal to the square root of x and below by y is equal to x minus 6. Okay. So which one is the square root graph? Is this a square root graph? No, it's the one that curves, right? So this is going to be your square root of x. And this is going to be your x minus 6. Okay. So this is a tricky one because if you're looking at this picture, the gray shaded area, remember it's top function minus bottom function, right? So here, is this the bottom function always? And the answer is no. So the reason why is because up until this point, do you guys see how this right here is the bottom function? What is this function right here, even though they didn't tell us? Is it x equals 0? Y equals 0. So this right here is y equals 0. So this is what this was for. So from here, what x value is right here? 0. So from 0 all the way to, when is this not the bottom function anymore? When we get to here. So what I'm going to do is I'm really dividing this into 2 areas. It's going to be from 0 to 6. From 0 to 6, what's the top function? Square root of x minus, what's the bottom function? Y equals 0. Do I have to write minus 0? Because that's not going to change anything, right? So I'm just going to put square root of x dx plus this area. So the bounds now from 6 to 9. Of this region right here, what's the top function? Square root of x minus, what's the bottom function? X minus 6 dx. You're not solving this, you're just setting it up. So that's just your answer. You good? Okay. Questions? Some of you guys are not great at hiding poker faces. I don't know if you guys know what that means. So if you guys have a question, please ask. We're good? Sure? Okay, now is your favorite part. We can use a calculator now. Find the area bounded by the curves of y is equal to the natural log of x and y is equal to 1/2 x minus 2. Okay. Y is equal to the natural log of x. I'm going to graph it and then I'm going to see how close I am. A log graph looks something like that. What type of function is this? Linear. So this is a line with a slope of 1/2 and a y-intercept of -2. So you guys agree it looks something like that, right? So what's really important here is if I want to know where these graphs cross, because this is a natural log, are there any e's or logs in this function right here? So most likely these cross at really ugly numbers. So what we're going to do is we're going to practice right now. Number one, this is my guess. Do I really know what the top function is or what the bottom function is? No. So this is important to graph the functions to figure out what is f of x, what is g of x, and then also figure out where do they cross, okay? So I'm gonna put this into Y1, put this into Y2. So let's go ahead and do that. Dang it, it logged me out. Was that pretty close? Remember, we did these in Math 3 honors and then pre-cal last year too. Remember, this graph actually continues down. It's just our calculator is like, meh, doesn't want to do it. Okay, so which one's the blue graph? So if you go to your y equals, your calculator also labels them as colors. So the blue graph is Y1, the red graph is Y2. And did you know you actually can change these if you want? Did you guys know that? If you highlight it, you can click on it and change it. So if you want it pink and green, live your best life. Should you make all of them the same color? No, don't do that. No, don't do that. All right, so this means that for my problem, since this is the higher function, this is going to be my f of x, and this is going to be my g of x. So my integral is going to be, do I have to type it out in my calculator, or can I just put y1? Just put y1, right? So it's going to be y1, because that's the top function, minus y2 dx. I'm not done yet, though, because do I know my bounds? No. So this is how you find your bounds. We haven't done this in a while. I would like to know where these graphs cross, right? So go to second, calc. Intersects, so you can just hit 5 on your keypad. Now, do you guys agree that's going to cross twice, right? So I'm going to scroll, if I can find it. There it is. Make sure you guys have your cursor close by where it crosses the first point. That'll be your A. And it's really important you guys find this one first, because don't we want to do it from A to B? You guys follow me? So as long as the cursor is close by, first curve blue, yes, so hit enter. Second curve, the red graph, yes, hit enter. Guess, yes, hit enter. And then boom. This is my A value. So based off what you guys learned this week, what should I do with this number? Store it. What should I store it as to make my life easier? A. So immediately from here, go to second quit. Store, alpha, A, enter. Okay, make sure your table is good. You guys good? No, I'm not moving yet. And then once you guys have that and your table is good, go ahead and try to find B. You guys good? You guys good on A? Okay. Alpha. Enter. There you go. Now do the intersect feature to find the other point that they cross. So in my graph, second, trace 5. So just make sure, guys, scroll now closer to where they cross over here. Hit enter, enter, enter. And did you guys get that for B? So now I'm going to go to second quit. Once I have that number, second quit, store that as B. Cool. If this is a test in my class, or are you guys doing the AP exam, as long as you guys write like these approximations down, So I would do this, and I'm going to assume that it crossed somewhere over here. Like that. Call this A, call this B. A was approximately what? 0.14. I don't have it on my screen, guys. Can you get it somewhere? 5.6. Kept going, right? Is it 5.6? Is that right? Okay. And then B was 8.21 what? What? 4? 1, 4? Why is this so hard, guys?
It's
09? Oh, I'm just going to do this because it doesn't matter. Okay? For this, I'd be happy with this. For your work, then you're going to say calculator. The integral from A to B of y1 minus y2 dx. Because remember, this was your top function. This was your bottom function. Your calculator has everything saved, so this is what you type into your calculator. So math 9. What is happening? There we go. Math 9, alpha A, alpha B. Your variables menu, so y1 minus y2 with respect to x. And this should be your area. Okay. Are you guys good? Does this make sense? No? Okay. Good? Questions? Okay. So to 3 places, 8.784. Okay. All right, last one. Nice. So the creators of these notes, guys, they're helping you guys out by throwing this on here because within the last 10 years, this has been an FRQ multiple times. So we're going to do one problem like this in your notes. There's 3 problems on your homework that have you guys practice this strategy. Okay? So let's read it carefully. Let R be the region bounded by the graphs 2 square root of x and y is equal to x squared over 4 as shown in the figure. If the line x equals k divides R into 2 regions of equal area, what is the value of k? Okay. So what I want you guys to see is this is our bounded area, right? Where does the area begin on the x-axis? 0. And where does it look like it ends? 4. Okay. What's half of 4? 2. Do not say the integral from 0 to 2, or find the area and then divide it by 2. That's not what I want you to do. Somewhere between here, there's some line that divides this into 2 equal parts. Our job is to figure out what that value is. Okay? So do we know what number this is? So what we can do is set this up as, where are we starting at? So the area from 0 to k, and then plus the area from k to where are we ending? 4. That's the strategy for doing these. And we have to do the calculus to do it. Okay? So this is how you do it. What is the top function? So this is a radical function, right? This is a quadratic. Do you guys agree the quadratic should be U-shaped? So that's going to be our g. That's our bottom function. Which means this is our top function. So this is going to be our f of x. This is going to be our g of x. So to find k, we're going to do the integral from 0 Understand it's 0 because that's where we start, right? We don't up to where it's cut in half, which is k, which we don't know yet, of top function minus bottom function. I'm going to rewrite this as 1/4 x squared dx. Since these areas are equal to each other, that should be equal to the area under the curve from k up until 4 of the same function. 2 root x minus x squared over 4, which I'm going to write like this. Why does it look like that? Dx. So we will need our calculator eventually, but the first thing you have to do is you have to actually take the antiderivative. Okay. Some of you guys have shown me that you guys can do this one pretty quick because we've done it a few times. Do you guys agree this is the same thing as 2x to the 1/2? So it's going to be 2 times x to the 3/2 over 3/2, but it's the same thing as multiplying by 2/3, right? Minus, what's the antiderivative of x squared? X cubed over 3, but I'm multiplying it by negative 1/4. So minus x cubed over, what's 3 times 4? 12. Okay. That's going to be equal to, oh, sorry. Oh, no. What am I doing? Bounds. 0 to k. Sorry. That's supposed to be equal to, if I take the antiderivative of this, do you guys agree it should be the same thing? The only thing that's going to change is my bounds. So it's going to be, I'm going to simplify it, 4/3 x to the 3/2 minus x cubed over 12 from k to 4. Okay, talk to me. Is everybody cool with that so far? So this is what's nice about these problems is it's going to be the same antiderivative. The only thing that's changing is your bounds. Okay? So let's think ahead. When I do this, do you guys agree I'm going to do top bound minus lower bound? If I plug in a 0 into here and here, what's going to happen? It's just going to be 0, right? So we don't care. To plug in k, all you're doing is you're replacing the x's with k's. So that's pretty easy, right? So this is going to be 4/3 k to the 3/2 minus k cubed over 12. Cool? This is the only part where you have to do some math because I have to plug in 4. Okay? So 4 raised to the 3/2 is the same thing as the square root of 4, which is 2, cubed, 8. 8 times 4/3 is 32 over 3. Okay? Minus, plug in 4, what's 4 cubed? 64. Minus, now I'm going to plug in k, but notice that it's the same thing. So minus 4/3 k to the 3/2 minus k cubed over 12. Okay. Is everybody cool so far? So remember I told you guys we're going to use a calculator, right? So we're almost there. We're almost there. If I distribute the negative here and distribute the negative there, since we're using a calculator, guys, I'm not even going to simplify over here. I'm just going to leave it like this. Minus 4/3 k to the 3/2 plus k cubed over 12. Now, Because I want to solve this, your calculator can actually solve this for you. So what we're going to do is we're going to get all the things with k's to that side, and we're going to get all the things that are just numbers on the right side. So I'm going to move this to this side. So basically I'm going to add 4/3 k to the 3/2 to that. Does that make sense? Because they're both the same term, just the number is different. So if I add this to this side, what's 4/3 plus 4/3? 8/3. So this will be 8/3 k to the 3/2. If I subtract this from both sides, whoa, what just happened? That was weird. Sorry, guys. If I subtract this term from both sides, I'm going to get negative 2k cubed over 12. And yes, I know that reduces, but I'm going to put it in my calculator anyway, so I don't care. Is everyone cool with that? Equals, since you're using a calculator, I would not simplify this. I would just leave it alone. Okay, the solution to this is where they cross on the x-axis. So now what you're going to do is you're going to put this into y1, put this into y2, and see where they cross. Can I use yours as a guide? Oh my God. 8/3 x to the 3/2. And then what is it? Minus 2. And then 32 over 3 minus. Thank you. Did you guys get something that look like that? Okay, so here is the important part to make sure you guys are paying attention. How many times does this red line cross a blue curve? Twice. Okay, but what's important is what's A and what's B according to the graph. You want to find whatever the answer is has to be between 0 and 4. So which point of where they cross is between 0 and 4? The first intersection point or the second intersection point? The first. So you only want to find that first intersection point. Why is this not working?